Hello everyone, this is Jóhann from Flowcore. Today we'll be demonstrating how you get the data from the data core into the adapter, restructuring that data, and then pushing it into the external source, which in this case was planet scale. Now, if we hop over to the scenario just to show you where we got off last time, this is what we did, that we took the data from a data core, passed it through an adapter. Now, we didn't do anything to the data. We just took it as it was from the data core into the adapter and then sent it right to the external read model, which in this case, again, was planet scale. Now, what we're going to do different this time is that we're going to take the data from the data core, pass it into the adapter, where we're going to transform the data by adding additional properties to the general data that we want exported into the database. So that's what we're going to start with today. Now to start, we'll just quickly create a new node here. We'll just branch out from this one. And then we'll pick Santa's Workshop. That's fine. And as you saw before, this thing that I mentioned previously, you didn't have to consider it. Now we do have to consider it, which is that which language would we like to transform this data from the data core in? In this case, we'll just pick TypeScript for now. And this is where these fields become relevant, because now, as you can see right here, the artifact URL, this is a literal URL to a package that has been generated within GitHub. And this is what we'll be making so that we can fetch the data from GitHub, like the transformation code from GitHub, run the code to transform the data, and then push it to the read model. So to start, let's just hop over to GitHub, and we'll search up flowcore.io. Here we go. Now, again, you are completely free to do it in any way you want. We have 2 example projects so far, which is to transform data using TypeScript, and one is to transform data using Python. Now, just for today, we're just going to stick with TypeScript, but the general experience is the same. So if we will show you the one, but the other one is practically identical. It's just in a different language. To start, I think we'll just hop into this TypeScript transformer example, where it will show you the code itself. This is all just boilerplate code that we can adjust ourselves. And as you can see up here, you can press use this template and create your own repository. Now, you might have noticed that in Flowcore, you just provide a URL and you create your own repositories. The idea behind all this is that the code, the transformation code itself, you own the entire thing. We never claim to own any of your transformation as well as any of your endpoints that you push the data to. This is to make sure that you are in full control over whatever it is you want this data to do. I have already set up a project, a GitHub project, which uses the Node.js TypeScript transformer example by pressing that one and create new repository. If you want to create your own, I recommend you read this README file, which goes step by step through how you set up your own. And there's even a YouTube video right here that you can tap, which will guide you through it one by one and linking back to this README and stuff like that. So it should be very simple to get through. Now, if you have any questions, then obviously just toss them in the comments and we'll make sure to look at them. So for now, I think we'll just hop over to the example one I created previously. And this is it. Now, I haven't done anything to it yet besides following this README file, so to make sure that everything is functioning as expected. So to start with, I think we're just going to press the dot symbol so that we open up the live editor within GitHub. And here we are. To start with, we'll just create a branch as it's shown in the README file. So we'll call this one adding additional, I can't even spell, but it doesn't really matter. We'll just call it whatever, additional properties to the best weather data. We'll just call it that. It really doesn't matter what you call this branch. It's purely up to you based on what you're doing. Now it comes down to that we want to take the data from the data core, transform it, and then push it into the read model. So this is where this happens within the under source transform.entryPoint.ts. This is where we transform the data. So if I just remove this one line just to simplify it a bit more, here we go. Now this is it. The input is the data from the data core itself. So this is the raw data. And the output, which is this bit, is the data that we want to, basically the outcome of the transformation that we want to push into the read model. To start with, we should probably analyze what data is within this data core. So we can hop over here, and I've already opened it under data cores, the best weather data there. And here it is, Santa's Workshop. Now we can see we have temp C, wind speed underscore MPS, and wind dir right there, all of which have various inputs or various data right there. We want to set up a quick little model that handles that. So we'll just create a type, call it payload, and it had temp C, type string. It had the wind speed, MPS,
string. And finally, it had the wind to string. So this is the payload that we would expect to receive. So this is purely just TypeScript code to make sure that it is type safe. So now that I can write input.payload. And there you see the temp size. Now that we have the structure and we can access the data itself, we can quickly hop on over to the test folder under expected. This is where you can set up a very quick, simple little test case to make sure that the data matches what you expected before you actually put it out. This is just so it lowers the amount of headaches you would otherwise get. Now, bear in mind that all of this is just purely boilerplate. You don't have to actually use any of the code that's in here. You could technically just take whatever you need, pull it out, and put it into your own repository. We just set this up so that it's a bit quicker to get started, and then you can always adjust it later. And again, because this is purely your own code, you could technically also call an external API or a source that you could maybe get some additional data that's related to your company or your needs, maybe other related weather data in this case that we don't specifically have within our own data core, but someone else has somewhere else on the internet. So you could technically access that through here and then pass that along. But for simplicity's sake, we'll just stick with the data that we have. And then, so let's just go back to test. Expect the JSON, and then here we'll be sure to add what the expected input fields are for this little test case. I'll just quickly open my notes because I just stored them beforehand, so it's quicker. There we go. Now, as you can see, this is the data I expect to come in from the data core. So I just set up a little use case that if this data comes in, I expect this data to come out. And then we do the same with the second test case. Again, if the data is slightly different, you want to test several different edge cases, then you can just keep adding these inputs downwards, input and output. Then we'll paste this one in here. There we go. As you can see here, the example that I want to go with is that we generate what is the distance between the temperature that we decided to pick here, which is negative 19, and the optimal heating. So that could be like the optimal heat within a building. So what is the difference? So like what's the distance between those two numbers? This is just some random example. You can completely control it in any way you want and decide, use it for whatever is related to you. But with this specific example, that's just what we're going to set up. So to start, we're just going to set up a simple constant called optimal heating in temp. Call it 22 degrees. That's the optimal heating within the building. And then we'll try to get the temperature from the data core. So we'll say temp in number. Since it's a string, we'll make sure to convert it first. We'll say parse float input.payload.tempc. This is just to convert it to a number so that we can add it up or do mathematical things to it. So we'll say distance between temps, and we'll say it is the optimal heating in temp minus the temp in number. There we go. So this is just subtracting it. Now, it's not a very complicated thing to do, but it's just so we can demonstrate that the platform works. And then we need to make sure to grab the name that we expect to pop out from the other end when it goes into the read model, paste it here, and set it to be the value of that distance between temps. And just to make sure everything is all right, yes, we have these event IDs, everything's fine. In that case, I think we can just push this up. Now again, what you call these commits, please refer to the README file, which should explain exactly what you should type and when and why and stuff like that. So just have a quick look through the README file if you haven't done that already. So in this case, we'll call it feet and then say edit optimal heating distance. There we go. We'll push it up just to make sure it syncs properly. There we go. And then we'll hop back to the repository itself. Just have a look at the pull request to see has it popped in yet. Now there we go. We'll create a pull request. There it is. And now it's currently running through the test to make sure that we didn't do anything wrong. It didn't mess up in any way. Once that's done, we'll make sure to push it out properly so that we can use it within Flowcore. And there we are. Seems to all the tests have passed. Everything's fine. So we'll merge it in, confirm merging, which should then, we'll just delete the branch for now, just to keep it clean. And now it is currently in the process of merging that in. So we'll just wait for that to finish. There we go. And now it is generating a new pull request, which is basically just telling you this is the next release that's coming out. So once I commit this to the main branch, it will have added a new release called 1.00. So once we press this merge pull request button, it will have generated a version 1.00. There we are. It seems to have finished. We'll press merge pull request, confirm merge, and delete the branch just to keep it clean. There we go. Hop over here, and it should start merging everything in now so that it will actually create a new release for us. Just that one. So we'll just wait for this one to finish. There we are. So let's hop over to the code part. Now, as you can see, the release has just popped up right here, version 1.0.0. If we hop in there, we can see that it has generated these 3 files. Now, bear in mind, if this file doesn't pop up straight away, then you might have to wait a little bit longer because it will start an additional action, which is to actually build the artifact. So if you don't see this one just yet, just hop over to actions and see if it's still doing something. For me, it finished. Now, the fun part comes now when we want to use this code within the Flowcore platform. So let's start out by copying the link to this zip file by right-clicking and pressing copy link. Hop on over to Flowcore, hop into our scenario, pick the one we had before just for simplicity, and then we'll just create a second adapter. Branch out, you will use Santa's Workshop, TypeScript. We'll paste in the artifact that we just generated. And here you have the option to pick the various versions that you'll get. For now, I'll stick with that one. And then how to execute the code itself. Is this a specific TypeScript where you specify it is executed by running main.js? And how many concurrent requests you want to be able to take. So this form could potentially change in the future. So just keep that in mind, and we'll make sure to make new videos if and when these things might change. But for now, this is the URL that we specified. This is the transform that we created right there. Press complete, and we'll push it into the same read model we had before, which is that one. And we'll just let it name it whatever it wants. And here we want to make sure that we specify the new property that we just added. So let's just hop on over to here, just to see what it was called. And hop into source, and we'll go into functions, transform. And that would be this one. So we'll grab that one, up over to Flowcore, paste it in. And the types that we want to specify here is a decimal. There we go. Now the formatting, we don't really need to worry about that. It'll clean itself up once we deployed it. And we won't be touching any of these for now. We'll make a separate video specifying what these different bits are and how you use them. So for now, we'll just leave it at that and press complete. Oh, jumped all the way over there. Let's put it over here and let's just realign it. There we go. Press save and deploy. And then we just wait for this guy to finish deployment. There we go. Let's hop over to the database to have a look. And it has generated the secondary medium. We're just waiting for the data to get loaded over now. So I'll just leave that to run for a bit. There we go. As you can see here, we now have this additional property called distance from optimal heating, which is the one we created earlier. And that essentially demonstrates how you can quite easily transform your code on the fly to add additional fields to whatever data comes from this data core. Or even if you wanted to maybe not even use wind direction or wind speed, but instead convert it to meters per hour or miles per hour, you could easily do that on the fly within the transformation code itself. The idea now is that you could always go back to your transformation code, hop back in here, press the dot symbol, or clone it down depending on your needs. Hop in here into the function, transform entry point, add additional fields or adjustments or whatever it is that you need to do to transform this data that you're working with, and then pop back in here, adjust the adapter, and then load the data into either the same table or a different table. So you can just keep iterating through that process until you get exactly what you need. So I think for now, I'll say thank you for watching, and I will see you in the next one.